Comets and asteroids are truly the time capsules of our galaxy, with many of them dating back to more than 4 billion years ago. These prehistoric treasures hold the lost tales about the origins of our solar system, and luckily, we are slowly starting to unravel its story. Missions like NASA's OSIRIS-REx and JAXA's Hibisua 2 are providing insight into the history of our solar system and even how life began on Earth. So, what's next? Hello, and welcome to another virtual episode of NASA Science Live. I'm your host, Tahira Allen, and today we're talking all about one of NASA's upcoming asteroid missions, Lucy, the first spacecraft to study the Trojan asteroids, which orbit the Sun in two groups, one in front of Jupiter's path and the other behind it. Once launched in October 2021, the mission will complete a 12-year journey to 7 different Trojan asteroids that may hold vital clues to deciphering the history of our solar system. But before we get started, let's take a deeper look at these objects. Great, so now that we learned a little bit more about this exciting mission, let's talk to some of the experts behind it. I am thrilled to be joined today by Dr. Adriana Ocampo, Lucy Program Executive at NASA headquarters, Dr. Kathy Olken, Deputy Principal Investigator for Southwest Research Institute, and Jessica Thompson, Project Systems Engineer at NASA Goddard. Ladies, thank you all so much for being here today. And to kick things off, could you help us understand a little bit more about what a Trojan asteroid is?
Yes, thank you for that question. Let's see, if we go back in time to a point about 4.5 billion years ago, when the early solar system was formed, we would have seen a dense cloud of interstellar dust. Then this dust would have collapsed and formed the solar nebula, which started to spin absorbed by the gravitational force. And that is what grabbed that material and started forming the early planet solar system. And the Trojans are really the remnant of that planetary formation process that formed planets like Jupiter, Saturn, Neptune, and Venus. We are very excited that for the first time we're going to go and explore the solar system with the Lucy mission in this epic voyage of 12 years. And the launch countdown has already started. We are only at 10 months and 12 days from the opening of the launch window in October 6, 2021.
There are thousands of asteroids out there, and Lucy will fly by them between 300 and 600 miles away, allowing us a close-up view of all the detail on the surface. These asteroids are in a unique position in that they are clustered in Jupiter's orbit at the Lagrange points. Lagrange points are places in space where objects tend to stay put due to the gravitational pull of two large masses nearby. The forces on these small bodies put them in equilibrium, meaning they're trapped in place, allowing Lucy to fly to them and image them easily.
And one of the really intriguing aspects of the Trojan asteroids is that they're a diverse population. From astronomical observations, they appear to be just a point of light, but that's enough information so that we can see some of the surface properties like color and surface composition. And we can see that there's a wide range. Some Trojan asteroids are more red than others, for example. And this is an image of two of our Trojan targets that Lucy will go and visit. This is Patroclus and Menecius. This image was taken with the Hubble Space Telescope. And these targets are really interesting because they are a binary system and they're about the same size. So they orbit a shared center of mass in between them.
Wow, so what we already know is fascinating, and I'm wondering, why is it important for a mission like Lucy to study them?
Well, the diversity of the Trojan asteroids is a clue that they really had a very interesting history. If they were formed in the location we find them in today, we would have expected a much more uniform population. But we don't see that. And there's some current theories of modern theories of solar system formation that involve the migration of giant planets away from the sun, and this causes a chaotic disruption of the small bodies in the solar system. And we believe that this caused some of these bodies to be ejected from our solar system and others to be trapped in these Lagrange points, forming the Trojan asteroids that we see. And for these reasons, over the course of 12 years, we're going to visit 7 Trojan asteroids with one spacecraft.
So to add to what Kathy just mentioned, one of the key questions that we have in planetary science is where did the molecule of water and the organic material that sparked the life as we know it in our planet came from? And asteroids hold the key to these questions. And by studying the Trojan asteroids, the Lucy mission will shed light to this enigmatic question on how life may have arrived to Earth. Lucy will not only investigate the Trojan asteroids composition, but it will also be able to inform the relative age and the chronology on how the processes happen in the formation of the solar system.
Wow, I mean, this is all super incredible. And so, Jessica, I actually heard that the name Lucy has a tie to the Beatles. And I was wondering if you could elaborate on that.
Yeah, it absolutely does. Lucy is named after the hominin skeleton fossil that was discovered in Ethiopia by Donald Johanson. And upon discovering this skeleton, the team celebrated looking to the stars while playing the Beatles song Lucy in the Sky with Diamonds, which led to the name of the fossil. And just like the discovery of this skeleton taught us about the origins of humanity, the Lucy asteroid mission will teach us about the origins of the solar system.
Wow, I mean, Lucy has a very big task at hand, it sounds like. And I'm wondering, what are some of the instruments that the mission has to complete this?
That's a great question. So, although we can't see the characteristics of the Trojans very well from the ground, Lucy has 5 cameras on board that will capture close up images in different wavelengths. The LORRI instrument will take pictures in the visible spectrum, similar to your iPhone camera, but more sophisticated, which will allow this mission to be able to get a great view of the geology of the surface. Lucy also has a thermal camera named TESS that will take pictures of the temperature on the surface, similar to seeing a body heat picture of yourself. And our third camera is kind of a 2-in-1 camera called Ralph which takes infrared and visible color images by scanning the surface of each asteroid as Lucy flies by.
And also we have a very interesting experiment on board the spacecraft that we call the gravity experiment. We actually use the high-gain antenna that you can see here, the circle in silver. And this is a collaboration with the German Space Agency. And the gravity experiments will help us determine the mass of the Trojan asteroids as the Lucy spacecraft fly by them. This is a very sensitive experiment that will enable to determine any deviation on the spacecraft trajectory as it flies by the Trojan asteroids. And in that way will determine the mass of or the amount of matter that there is in these objects, and from there, their density.
And we also have 2 terminal tracking cameras on board. These are part of the guidance and control system of the spacecraft, but we'll be able to use these cameras to collect wide field of view images as we fly past. You can see them at the top of this graphic. This is our instrument pointing platform where our cameras reside, and it's the 2 small objects, round objects at the top. And we will use these cameras to be able to get the volume of the Trojan asteroids through imaging. And combining the mass and the volume, we'll be able to learn about the density of our Trojan asteroids. Using all of these instruments together, we're going to be able to investigate the geology, the surface composition, their internal properties, and search for satellites at these Trojan asteroids. It's going to be a great first reconnaissance.
Wow, and this just sounds like a really complex piece of technology. And I'm wondering how many people work on this mission?
Tahira, that's a great question. There's approximately 750 people that have been involved with this Lucy mission. Lucy family is really a big mix of engineers, technicians, scientists, managers, and even interns. Our team is truly the key to our success, and it's been very motivating to work with people from multiple organizations and universities. And I'll tell you, each and every person's role and experience on this mission has been vital to designing, building, testing, and soon to be launching this spacecraft.
Wow, that is incredible to know that so many people come together for one amazing object. But I do want to go back to an animation earlier in the show because it looked like there were swarms of Trojan asteroids in front of behind Jupiter. And so I'm wondering if we were standing on one of the Trojan asteroids, would we see many of them around us?
While these green dots look like they're really close together, the animation doesn't convey how vast and empty space actually is. It wouldn't look like the Millennium Falcon flying through an asteroid belt dodging asteroids. Of the about 5,000 known Trojan asteroids in each swarm, they're each separated by about 9 million miles. So if we were standing on a Trojan asteroid and looked out at them, at the other Trojans there, we actually wouldn't be able to see them with our eye, or at least not many of them, because some of them would be as faint as a 10th magnitude star.
Wow. Okay. Those movies are very deceiving. Thank you for putting that into perspective for us. And so I am seeing a lot of great questions roll in from users online. And if you are watching now, please don't hesitate to join the conversation with us. Submit your questions in the comment box where you're viewing from, or by using the hashtag #AskAnASA on social media. So ladies, to kick things off, I have Nope, Nope, Nope on YouTube. Jessica, I think this is a good one for you, who asks, will Lucy be sending data and photos during the mission?
Yeah, great question. So Lucy has a two-way light time of about 45 minutes to send commands and receive data. So we'll have the first images back within a few hours after flying by the first asteroid, which is Eurybates. We'll be there in 2027.
Nice. That is so exciting to hear that they're coming back. And so, Kathy, I've got a great one for you. Um, Inshan on YouTube asks, what is the composition of a Trojan asteroid?
Well, that's a really good question. So they have different spectral types, and that's how we can tell about the surface composition. And they look like some of the asteroids in the asteroid belt. We call them, there's C, D, and P type asteroids that are in the asteroid belt or in the Trojan asteroids. And one thing we really want to know when we visit with Lucy is, what is the composition? Is there water near the surface? What other what are the densities of these objects? So part of the reason we're going to visit is really to answer that question. And from the ground, we can see the overall composition of the surface, but to see surface details that aren't resolved, we'll really need to send a spacecraft.
So, actually, Kathy, I've got a great follow up to you. So, John on Facebook wants to know, will we know where the asteroids originated?
That's a good question, and we're going to be trying to answer that question. And by looking for ices that are stable at further distances from the sun, if we can find those on the Trojan asteroids, that's going to be one key clue to where they had originated. The ices that are closer to the sun evaporate and they're not stable. So this is going to be something we're looking for when we fly by starting in 2027.
Nice. Okay. Adriana, Lori Jones on Twitter asks, if the Lucy mission is successful and provides good data, are there plans for future missions such as Lucy's?
Yes, that's a great question because, in planetary exploration, what we have learned is usually we fly by objects, by planets, and then the next step is to orbit that object and then to land. So we are planning and we'll be having calls out by the scientific community to propose the follow-up missions to the Lucy mission. So a lot more to come. This is just the beginning.
So I'm interested to know, there was NASA's OSIRIS-REx mission was recently in the news for its first tag sample. And how does that mission compare to Lucy's?
So the OSIRIS-REx mission.
Go ahead, Kathy. Yes.
Thank you, Adriana. The NASA has a whole suite of asteroid missions that work together really synergistically. And OSIRIS-REx is one of them. And the upcoming mission Psyche to a metallic asteroid is another. And all of these missions really give us different clues about not only near-Earth asteroids, main belt asteroids, but also Trojan asteroids, so that we can really piece together how the planets in our solar system formed and evolved.
Thank you for that. And so, ladies, this is really for whoever wants to take it, but Jim Bloodworth on YouTube asks, when is the launch and on what rocket?
Oh, I'll take that one. We're launching October 16th, 2021 is the opening of our launch period. And we're launching on an Atlas V. ULA is partnering with us on that one.
Nice. Cannot wait. We are under 1 year to launch, everyone tuning in. So, okay, here's another one. Aramus, sorry if I'm messing that up, on YouTube asks, can you see the asteroid with a telescope?
Yes, I'll take that one. We can see the Trojan asteroids with a telescope. And in fact, recently we discovered a small moon around one of our Trojan targets that we're going to. Our first target is called Eurybates, and we recently discovered an approximately 1 kilometer size moon from the Hubble Space Telescope. And so this is an example of being able to see the Trojan asteroids through a telescope, and also being able to search and learn more about these interesting targets before we get there.
So,
We'll just,
can, oh,
I will,
sorry.
sorry, I will just add that the name of the new moon that was just discovered is named Keta. So it's a new discovery that the Lucy team made with the Hubble Space Telescope.
So,
Yes,
on the topic of discoveries, oh, sorry, continue.
I just wanted to add about that name. The name is in honor of the first woman who was the Olympic torchbearer. And so we're really happy to be able to name this small moon in honor of Enriqueta Basile.
Wow, thank you. That is a really fun fact. But on the topic of discoveries, Alex Mann on YouTube asks, can Lucy theoretically discover new asteroids on her way through the asteroid belt?
I can go ahead and take that. It is possible that Lucy could discover asteroids either in the Trojan asteroid swarms or potentially in the main belt, but it's unlikely. Our telescopes have a very narrow field of view, our instruments do, and so we won't be trying to search a broad area to find new main belt or Trojan asteroids. The real purpose is to get our first close-up look at the Trojan asteroids that we'll be flying past.
Nice. So, Jessica, I want to go back to what you mentioned earlier in the show, talking about how many people worked on this mission. And I'm curious to know, how long have these groups been working on this mission?
Oh, wow. So the discovery proposal for this, I believe, was started back in 2014, and Lucy was awarded in 2016. And so we've been working as a formal team since 2016.
Wow, and to all come together in this one big moment next year. That is so exciting. And ladies, I've got a really great question for whoever wants to take it. Rayhan on YouTube says, will any of these asteroids hit Earth?
Well, I can start, but I probably lose. Kathy could follow up. No, these asteroids, the Trojan asteroids, are really quite far away. They're, as we mentioned, in the Jupiter's orbit. So for them to be, if there would have to be a major collision to deviate their orbit to bring them closer to the inner solar system. So there is no potential of impact from the Trojan asteroids around the Jupiter orbit.
Yeah, and I can just add that because they're in these Lagrange points, which are stability zones, these objects are not going to escape and then impact Earth. And what that also means is that this is probably a specific population that's not represented in our meteorite collection on the ground, making it even more important to go visit these Trojan targets with our Lucy spacecraft.
So, Kathy, earlier you mentioned that if we were standing on an asteroid, we wouldn't necessarily see the next one right around us. And Gerald on YouTube asks, how long do you think it will take to go from asteroid to asteroid?
Oh, that's pretty interesting. We have this really amazing trajectory that enables our voyage through the Trojan asteroids. And you can see it here in this animation. This is in a frame rotating with Jupiter. And so the blue line is the Lucy trajectory. And we fly out, do 2 gravity assists past Earth to pump up our aphelion so that we can get to the Trojan asteroids. Then we fly through the L4 swarm, visiting 5 different Trojan asteroids. First, we visit, like I said, Eurybates and its moon Keta, and just 30 days later, we fly past Palomili. But it's not until years later that we fly past Patroclus and Menecius later in the L5 swarm. So look forward to encounters with Trojan asteroids from 2027 to 2033.
Wow, nice, for a long time. And Jessica, Doggy Gamer 13 on YouTube asks, how fast will Lucy be going?
Well, when we're flying by the Trojan asteroids, we fly by between 6 and 9 kilometers a second. So that's kind of like doing a 10K in less than 1 second.
And one thing
Wow,
I'd like
thank
to
you
just
for.
add to that is imagine as we're flying by trying to take images at those great speeds. And part of the really interesting engineering on this mission are those terminal tracking cameras that I mentioned, and they're mounted on an instrument pointing platform. And that pointing platform can move so that we can remain targeted on the Trojan asteroid as we fly past at such high speeds.
So, Kathy, do you know how good of resolution are we talking about with these images?
The resolution is going to totally transform our understanding of these Trojan asteroids. Our highest resolution images will be about 14 meters per pixel. So you will be able to see geologic features on their surface. We'll be able to count craters. It's going to be so exciting.
Nice. And so this is for everyone. Astro Girl on Twitter wants to know, why are there so many asteroids between Mars and Jupiter?
Well, I can start it, and then I'm sure Kathy or Jessica can follow up. It's important to note that the Trojan asteroids is a different family from the ones from the main belt, which reside between Mars and Jupiter. So, and again, we have visited the main belt asteroids with many other missions, and we are planning to continue that operation. Is a set of a family of objects that are extraordinarily important again to understand the chronology and the formation of the planets within the solar system. But the Trojan family that as I mentioned, we have mentioned that it has never been a study, and they are the remnants. During the formation of the system, there were great collisions, and as well, and there were fragments. And so a lot of this is the material that did not accrete sufficiently to form planets. So these rocks that were left over from the planetary formation during the early solar system, and that's why we have so many asteroids or these objects in the main belt, in the Trojans, and as well far, far away in the Kuiper belt. So they're all different families, and they relate, and we're trying to understand them, what the relationship is.
Thank you so much. Unfortunately, that's all the time we have for today. I feel like we could talk about this mission all day. Adriana, Kathy, and Jessica, thank you so much for joining us. And for those tuning in, thank you for watching, and thank you for those great questions. We are less than 1 year away from Lucy's October 2021 launch date. And be sure to visit nasa.gov/Lucy for more information about the mission. And if you want to stay up to date on mission milestones and activities, be sure to follow NASA's Solar System on Facebook, Twitter, and Instagram. Again, thank you so much for tuning in, and see you next time.